radial basis. Okay, radial basis. And another one is sequential. Sigma or a linear. So what is the hyperparameter for the RBF? What is the hyperparameter for RBF? अटेंड नहीं करे कल, अटेंड करे या नहीं करे? इस गामा क्या होता है? ढूंढ रहे हो क्या वहां पे? कोई बात नहीं, ढूंढ के सर्च करके बता दो, कोई दिक्कत नहीं. इफ यू फाइंड द राइट आंसर, दैट इज मोर इम्पोर्टेंट फॉर मी. Curvature. So gamma will say the curvature of the line, the curveness of the line. And what is a C? C is a hyperparameter for which kernel? C is a hyperparameter for which kernel? Linear kernel. Linear kernel is a C is a hyperparameter, guys, not sigmoid. Sigmoid is used for where you use the sigmoid, where you use the linear, where you use the RBF. आपने अटेंड नहीं किया कल, क्यों? इसमें से निकाल देता हूं, सही रहेगा, तब सब लोग अटेंड करेंगे, आके पूछ के अटेंड करेंगे. हाँ बोलो. When you use the linear, you didn't attend it. So what you are doing? Sleeping. हाँ रामू, మంచి బాలుడు చెప్పు. అబ్సెంటా? చూస్తా, నా దగ్గర తీసేస్తా చెప్తున్నా నేను. I will remove from the WhatsApp and I will block it. Enter आने नहीं तो क्लास के अंदर. So linear is used when the data is linearly separable. When the linearly separable data is there, then you are going to use the kernel linear. When or linear or polynomial, both. Polynomial is very rarely we are going to use it. The next one is RBF. RBF is used when the data is non-linearly separable. When the data is non-linearly separable, that means the data you cannot separate it with a one single straight line. In that case, you are going to use it the RBF. Okay, and RBF is okay. Sorry for that. Now RBF use the hyperparameter called as gamma. Now whenever there is, now you take it like this, it's a basic understanding. If there is a data is there like this, there are some X stars are there over here. When there are can you hear me? Now. Okay, thanks. Now, when data is like this, guys, just see this. These are all circles. Now, this can be separated by a straight line. When there is a straight line is there. Now, straight line is this is called as linearly separable. Now, when you are able to separate the data like this, then there is no need of any curvature of the line. There is no need. Straight line will not have any curvature. Suppose if the data is non-linearly separable, here and some zeros are here. Now this one you will be separating it like this. This is where you will have the curvature. This kind of problems we use the RBF, Gaussian RBF. By default, that is the one we will be using it. But this is the one which is used. Now this is what is called as curvature. This line is having the curvature. This is a gamma. There where there's the gamma. Clear? Now let's implement this one, guys. Hope you are clear with this now. So let's the implementation. There is a what do you call it as cancer data is there, right? We will take that cancer data and we will try to implement it with the first we are going to implement it without any hyperparameter tuning. Then later we will do it an hyperparameter. Okay? I think that you have the cancer data, right? You can download it directly from the load cancer data will be there. You can download it. So I think that I shared you all the code now. You don't have anything left out with you, right? So all the code is there with you. Now SVM. So import pandas as PD. Okay. Import numpy as np, and we are having a scalar from a scalar dot data sets scalar dot data sets import load cancer data set here. Now I will use it like cancer data. Is equals to load underscore cancer. Now this data will be in the form of dictionary, guys. This data will be completely in the form of dictionary. Now in this is the actual data. Remember this. Now let me give you, this is a dictionary. Data cancer dot keys. This is again a dictionary keys. Data is the first one, followed by that target followed by the frame. Now ignore the frame. Target name. What is the target name over here? Now you see this is the major data, guys. And after this is the target. This is my dependent. Okay? And this is my independent. Remember that. This is my independent, this is my dependent. And this you can ignore it. Target name. Two will be there. One is called as malignant and benign. So malignant is the one which is the actual cancer. And tumor, when the tumor is of malignant, it is the actual cancer. This is not an harmless cancer. Tumor is. So here 0 will be the malignant and then will be 1. Okay. Now here all the description over here. Now another important one is feature name. What is features, guys? Column. Names means feature names. Now this data set is already there over here. Your local drive, already it will be downloaded. So I don't wanted you to do this. I want you to do this one. First one is my data. Here data cancer of data. This will give me the complete data. This I want to convert it to my data frame. ed.data frame over here. Okay, guys. Now this I will give it as df cancer. Now you see this df cancer is the one we got it. But we don't have the column labels over here. I want to give the column labels. Where are the column labels? Where are the column labels inside this? Huh? Feature names. Feature names is a column label size. This I want to give it as a column. Here you see columns is equals to data cancer of the name feature. You should get it. There is an error. Of cancer. Huh? Now you see this, I got leads. Okay. Now I didn't included the target inside this. Now my data frame looks pretty perfect for me now. What is the target, guys? My target is again this. Here you can see the target values. This is my target. So how I'll get it? Df and data cancer of target. Can you do it? This I want to convert it to ed dot data frame, and inside this I will get a column label as cancer. Column labels target. Now this one I will say that df target. This I want to merge it together to show you actual the data set how it look like. So pd.concat df cancer comma df target. Access is equals to 1. Now you can see this. Okay, guys, clear? Now this is my complete data frame of the cancer. Now tell me which one you have to do it. First X is what? df cancer dot drop. Which one you will drop it? Target, right? There is a target. There is target. I did not put the target. So you can see the last one is target over here. This target, I want to edit target. You can use it like columns, guys. Target. This also you can give it, instead of using the axis X, you can give it column target. And it will be dropped off. Now, if you see the shape 30, 569, 30. Now, if you look at the shape of this one, you will get it as 5, 31 over here. So one of them is dropped off. Now next, what is Y? And target. BF cancer of target. Now Y is equals to this. Okay. Now split the data. I'm going with a normal thing. I will split the data from sklearn. What? कौन सा है वो? Model selection for splitting. Train, test, split. And train underscore test underscore split. This will split up X comma Y. Test size is equals to 0. Columns total 0.20. X train, Y X test, Y train, Y test. How can I do this? X can use it. Okay, now it's there. The data is there very clearly. Now I want to implement it with SVM from sklearn dot SVM import SVC. Now SVC here, if you check it out, there will be a lot of parameters, guys, over here. One is C. I told you C is controls the error. Now, kernel, you know it. This degree is specially for where the degree will come. We have seen the degree earlier. Polynomial regression. Okay, usually the degree will be 3. Now gamma, this scale is there or auto. The one is auto over here. Here, auto. Usually, if you want to go with the scale, is the default one. Auto is the automatically it will be doing it. Now, by default, the kernels. Can you see the kernels? Linear, poly, RBF, sigmoid, and computer. This is almost obsoleted, guys. So we are not going to touch that one. So these are the 4 of them we are going to look at. Okay? Now, these are the ones which are specially. Now, C can be 1 or 10 or 100, anything you can keep it. It depends. It's purely an hyperparameter, trial and error basis. So this one is also having multiple values. What are the multiple values? RBF, linear, sigmoid, and poly. You can use any of them. And again, this is again, and okay, you keep it as auto. It's okay. Now, tolerance is again a changeable one. You can change the tolerance all the time. Now, iterate, maximum iterations. How many maximum iterations you want to do it? That is what it is. These all are like, you know, hyperparameters. If one of them is changed, the whole structure will be changed. Okay. So let's see this one in our hyperparameter. As of now, I will keep it as it is. I will not change. I will say that AJSVC. Now AJSVC dot fit explain comma void in. Now here AJSVC dot score X test comma Y test. I got it 97%. Now is this score is correct? Let's do it with the now before applying, I want to do the what do you call it as feature scaling over here. How to do the feature scaling, guys? Feature scaling we are going to go with from scalar dot reprocessing import standard scalar. Okay, standard scalar. We are going to give it as SS. Now SS dot fit. We have to fit strain and only independent data. So what you have to train with strain and transformation should be done on strain and by-train. Now here it will become strain underscore SS and transform X test underscore SS. Okay. Now then I will apply one more time. Now SVC1 is equals to SVC. So SVC1 dot fit X train underscore SS Y train. I will give it. Now this is kind of training. Now after this SVC1 dot score X test underscore SS comma Y test. It is 98%. Definitely the score is increased. Now this is a triggering point, guys. Let me see this. What is the score of my training data? Look at the training data score. Train underscore SS by train. Good. So then it's okay. It's almost the same. It's learning good and prediction also good is there. Now, what if I will change the kernels? I want to change the kernels and I want to see it. So, first time I'm keeping it as RBF. Okay, now first one is we know that the kernel is, I'll take this one as it is over here. All keeping at one single place, guys, so that we can change it at one single place. Now I will give it as here. I have it kernel. Here, this is the kernel. Okay. Kernel is RBF, and here I will give it as 2, and 2, or I will give it as RBF, just to make you understand. RBF and RBF. Now it get me like Hmm? RBF? Okay. 98% we got it. Now let me try it out with linear. I got it same. There's no change at all. Is it wrong? I have to use, I have to change this linear. It is the same. It's the same. No problem. Now next one I will take it as sigmoid. Sigmoid, and here I will write it as sig. Here also I will write it as sig. $99. Huh? Sorry? क्यों ऐसा? ओवरफिटिंग कब होगा? ट्रेनिंग, परफेक्ट ट्रेनिंग with the prediction नहीं ना, यहाँ पर prediction हो रहा है. Okay. Now again, here I changed only one parameter. What is that? Kernel. Now what if the different values for the C? Now for one kernel RBF, just take it. I'm having kernel RBF over here. Yeah. Now you take it over here. I will take it as kernel RBF. RBF. Now for this, the C value I have to check it out for 1.0. C value I want it and for 10, and then I may check it for 50 or maybe for 100, something like this I can give it. Now this is only small. I can give it as 0.1.0 or 1.5.0 or sometimes 0.5. All these things you have to check it out. Now these things, if you go on doing it, like, you know, why you have to do it now when there is got the 99 point. So we have to see the stable one. It's not that now if my data is changed over here, here I'm splitting is changed. Okay. Now you see this here, this one. I will run it. Now it's changed to 96. Now again, it is a different one over here, 98. Now this is about the training. Now here it will be changed. Now this will be changed again, and this will be changed again. 93 it came down. Now which one you will trust? It's very क्रॉस वैलिडेशन तो करेंगे, लेकिन there is a hyper parameters also there, right? So each and every time change the parameter and you have to do the cross validation. That is a big headache. Now let's do the cross validation. What is that? How to do the cross validation, guys? Now this is what exactly happens in the real time. अगर हम लोग खुश होते ही ना या 99% हुआ, लेकिन immediately you will get some different readings. It is not possible. You can't say that every time you will get a 99%. If your accuracy is really 99%, that is a, you know, the most happiest thing you can have. But score, this is test score. Now here I will take it as cross validation. How to do it? From sklearn.model selection import k-fold or cross val score. Okay, guys. Now k fold, how much you want to give it? 10 splits. 10 splits is equals to 10. Then we are going to give it as kf. Kf. Now next is, so I will give it as cross val score. And then we will go with what? Which one? इसमें हम कौन सा कैसे डालोगे चारों इसमें डाल के फिर we will apply the for loop. Okay, clear? Now I will create a, now I have to create altogether new. I don't want to go with the old one. Why? I can use it like SV poly, SV sigma, sig, and SV linear and SV RBF. Can I use that? कर सकते हैं? You got it? Rohit, can we do that? क्यों? So, directly we can use it, this one, in the list, like this. अच्छा इसके अंदर वो दे सकते हैं SVC poly, SVC sig, SVC linear. Can I do that? Think. Right? You can't give it. It's already learned the data. It's already learned from the previous one and it is already in the comfort zone. अगर हम लोग we are trying to give some new data, it will not learn. It's already learned it enough, so it will not take the new one. Okay, so in this case we will be having SVC and I will give it as one more is what? RBF. Here I will create altogether 4 new algorithms, new objects of the algorithms, models in other words. I'll use it. This is the first one, SVC poly 1. I will use it. SVC kernel is equals to poly. It's poly only, right? Okay. Next one is, I'll write it as 1. SVC sig 1. SVC kernel I created sig1 over here. Now I'll give it the 2 more. Linear 1. Next one is RBF 1 lily. Linear 1 and RBF 1. Okay. Now, what are you going to do it? We'll do it for M model in algo. And we will take it just to make sure I got it all the 3. Okay, this is the default one, so that's the reason why it is showing it. Now we are going to use it cross val score of M, comma M is having the first poly, then next sigmoid like that, and then here we are going to give it what? X comma Y. Oh, I want to give the, I want to implement the standardization. How I'll do it? वो दे देंगे स्प्लिट करे सो वो दिए तो फायदा क्या है, हमारा स्प्लिटिंग ही रॉन्ग है ना, तो क्या करना है, what I said is you got it, is asking me to give it x train underscore ss y train underscore y train underscore ss or something like y train, but our splitting itself is wrong over there. We use the hold out splitting over there where you are splitting it one time, उसको repeat करें तो फायदा क्या है. So I want to repeat the test data and train data. How I'll implement that? How I'll implement it? Standardization. X देके करना है. So see guys, basic principle is where you will use the standardization, where you will implement, on which data you will implement the standardization, independent data, right? Now after splitting or before splitting, it doesn't make any sense at all. Okay, usually we will go with the after splitting because it should be the last point before giving to the model. But in the cross validation, whenever you are doing this X wala data hai na, you can directly apply the standardization. Apply the standard. How you will do that? I'm taking it somewhere over here. For this, I will do it. From sklearn dot model selection import model selection है ना, pre-processing import standard scalar. Now do I need to create a new object? Why? The previous one is already learned. Scale is equals to, here I will give it as standard scalar. Okay. Now what you are going to do? stdsc dot fit transform, applying same fitting and transform, learning and transforming, applying in the x. समझ में नहीं आ रहा? ठीक है. Now std I will date as x underscore ss. That's it guys, I've done it. So if you see the x, first wala x dot head, this one is there. Now if I give it our transformed data x underscore ss, it's already transformed. Perfect. Now in this case you can give it s underscore ss. That's it. Now cv is equals to af. Af here now. It's going on and on and on. Now I'll get the score over here, model score, m score, and I have to print the score along with standardization again. Okay, I will see standardization is which is applied on the independent data. So here when I am passing it, I have to pass on the independent data which is scale. So what I am doing is I am taking the independent data x and I am applying the standardization mechanism, fit and transform in one step. Previously we were doing the fit and then transform. Now we are doing it fit and transform in one step only, and I am getting a new form called as XSS. I am showing you the difference before transform and after transform. I am applying it for the each and every model. And I will print it over here. M model is equals to M. I will write it over here. Score format m comma and score dot mean. See this? I got the score. Where is the score? Hmm? Yeah. Now we got it, guys, over here. Which one is the best? With RBF. RBF is the best. Now every time you can go with this one. Is this the final one? Yes? Now we can go with this and we can say no. C bhi hai, gamma bhi hai. Gamma is there, C is also there. There are two more hyperparameters are there. How you are going to deal with them? So again, for each, now suppose if I take it like this, guys. My kernel is, what is there? My kernel is equals to, I'm giving it as RBF. Next is linear and sigmoid and poly, right? Now, if I take it my C value as C value, I'm taking it as 1.0 is a 1. There may be a chance that I may go with 0.5 also to take it out. And there may be a chance that 5 or 10, 50, 100, 150, something like this. Now, what you have to do it is, for each value of this kernel, you have to check it out with this one. Then you have to check it out with 1. Then you check it out with 5, 10, 50, and 100 and 150. How many times you have to do it? Huh? You have to use the nested loop. For each value of this, you have to pass it on this. So first for loop will be this one. Second for loop will be this one. For each value of RBF, you have to do this. And इसमें और एक भी है. You can give the gamma also. Okay. Now, if you go to the decision tree, the things will be even worse. Especially when you go with the random forest, even worse it will be. Like, you know, you will be having depth. How many random forests you want to give it? All these things comes into the picture. Then in that case, the only thing which comes to your rescue is grid search CV. Okay, that is called as hyperparameter tuning. They call it as hyperparameter tuning. That is done in the two ways. One is that grid search. Second one is called as random search. Two ways are there. So here, if now the advantage of one is if there are like 3 or 4 are there, 3 or 4 hyperparameters, it will go and test it for each and every possible thing, and it tells you the which one is the best. You don't need to worry. It will tell you the which one is the best. But the grid search is it will check it out each and every parameter, every possible move. Like suppose if I'm having over here scale and auto. So what it will do is like for first combination RBF with 0, 5, then it will check it out for the scale and with auto. Then RBF for 1, it will check it out for the scale and auto. For RBF with 5, it will scale with and auto. Like this, it will check it out. Now, if there is something else is there, like tolerance is there. Tolerance, I am giving it as 0.1, 0.001, okay, 0.001 or something like this. I have given 4 values. Now, this will be even worse. For each value of RBF, it will take it like RBF with 0.5, with scale, it will check it out all these values. So again, it will go back RBF with 1. That is, this is 0.1 with scale, or sorry, with 0.5 with auto, it will check it out. All the values and all the things it will do, all the possible moves it will do it, and it will make you, and like it will give you the best possible combination. Which is the best possible combination that is being clearly made by your grid search CV. Now there is a slight difference between the grid search and random search CV. What is a grid search will do is it will check it out each and every possible test. That is, now you check it out RBF 0.5 and then linear 0.5 scale auto or this. All the combination it will try. When it tries all the combination, definitely what happens is your time will be taken. A lot of time it will be taken. It will take a lot of time. And this will be very slow, a bit slow when the huge data is there. When the small data, this is a perfect one. When the huge data is there, this is very slow. So in this case, what we'll do is like, we will randomly say that how many iterations it has to do. Take 3, take 5. So it will take the best of the 5, best of the 3, and it is having its own mechanism. It will take the best of the 3 and best of the 5. So most of the time, all the software engineers will go with random search. When the data is very large, when the data is small, we'll go with the grid search. Now, hope you got it, how this grid search and random search works. So let's try it out with this one. That is an ultimate way of getting it the best. And in that also, we didn't use the multiple algorithms. We are using only one algorithm. Then you can use the multiple algorithms and forward to your grid search CV. That is what I was saying. It in the auto ML is, this is what exactly happens. Now, again, from sklearn, we'll be having a model of pre-processing. Import grid search CV or its model. Grid search. Okay. Now, this grid search CV, it will take like, if you check it out, guys. See, first one is estimator. Estimator is nothing but your algorithm. Okay. Then here the param grid. Param grid is nothing but your parameters. Whatever the parameters you want to give it, that is what is called as param grid. Now, n jobs is how many cores you want to use. Score is always false. It will not give us the score. Now, here you see this. There is something called CV. What is this? Cross validation. So, how many fits you want to make it, you can give it. Or you can give it your KF also over here. Okay. Now, these all are, you can ignore it. Now, these are the things which are important. This one, and this one. These three are really very important. How to form the param grid. This is the most important. Now, you will have something called as random search CV also over here. It is also the same, guys. See, estimator, param distribution. This is again whatever the way you want to distribute this. Now here, iterate. This is the extra one. How many iterations you want it? By default, there's 10 is there. It will be n jobs. All this. This is the one which is. These 4 are important things. Okay. Hope you got the difference between grid search CV and random search. Now let's do this one. First is, just forget about all these things. First, create your what is your hyperparameters you are having over here in your SV. The hyperparameters you are having, guys. One is the C, kernel, and gamma. Gamma we will keep it as auto, will not touch much about that. So, and tolerance is also there. As of now, we will leave it. We'll take it these two only. You can give the degree also. You can try the degree with a different also. So, this is 1, 2, 3, 4, and 5 are there with us. If you want to give it, you can 5. You can increase the size also. And max iteration. This -1 means it is unlimited iterations. It will go. You can give the max iterations also. Okay, -1 means unlimited. There's no limit for the iterations. Okay, so I will leave it all these things. We are going to take it only these two. So you want to try, you can try it out all these things. Okay, now what is hyperparameter? What is hyperparameter? I'm saying you hyperparameter. I'm implementing it. What is hyperparameter, guys? A parameter or a variable whose value can be changed. Okay, which is having it's not having a fixed value. Now this can be tuned. We don't have a particular value, we can't fix it. So the value, the variable or parameter whose value can be tuned based on the requirement is called as hyperparameter. The process of tuning this hyperparameter is called as hyperparameter tuning. This tuning will be done with the help of grid search CV. Okay, guys? Here. Now let's do this one. First is, let me see my aram. Just giving a variable like aram. I'm creating a dictionary over here. In this dictionary, what are the parameters I'm having? One is kernel. Next one is C. The gamma. I'm giving the C. Yes. Now let's see this one. Now you can see this. One is a C. Second one is a kernel. So these two I'm taking as a parameters, hyperparameters. Okay. I'll go down over here. Here inside this, I took the C and kernel. You see this C and kernel. Default is this one. Now I will give it over here inside this. First one is RBF. Second one is sigmoid. Next one is linear and poly. Now C value, what is the value? 1.0, and then I will give it 5.0 and like 20.0 and maybe 50 and 100. You can give it any number, guys. I'm giving only 4 or 5. You can try it out with different numbers. Now this is I'm done with my stuff. I can use the degree, I can use the gamma, anything I can use it. It's up to us. Now let me run this one. Let me run this one. I'll get it like. And make sure that the keys should be same as that of your value. Okay, whatever the variable is having the parameter, the same should be. Now let's see this one, grid search CV. Okay. Inside this, I'll give it as first is estimator. I'll give only one estimator, like any one you can take it. I'm creating as SVC, this one. I'll create a new one. SVC grid is equals to SVC over here. Something like this. Now here I'll give it as first one is estimator, right? This is not the one. First one is estimator. Now I'm giving the estimator as SVCG. SVCG. Then next one is, what is that? Parameter. Here I'm using this one. I can use this. It's not mandatory to give it, guys. It's again depends. You want to give it or you don't want to give it. Now next one is CV is equals to 10. And the next is what? One more. N jobs. We give it N jobs. Or just leave the N jobs. N jobs is how to use the different cores. There are different cores will be there in your computer. If you give N jobs is equals to -1, it says that it will use maximum whatever the cores available. It will try to use that. Now your processors. In other words, in the processors. Huh? Yes, whatever the instances are present, it will use it. -1 means it will use it. Okay, not giving anything like that. Now, in this case, it will be dedicated, which are dedicated, that will be used. Okay. Now, let me see if I'm missing anything else over here. Yeah, score is none, nothing. Fit is equals to 3. CV we gave it. Now this all is okay. Now let me run this one, guys. This will give me a grid object. Just like how we have the grid object, the same object, how we get the model object, the same way we will get a grid object. Okay. Now I will give it as name as SVC grid CV. Here I will say that grid model or something. Okay. Grid model, guys. Now I am going to run it. I prepared my model. Now this model is just like your algorithm model. Whatever we create the linear model or logistic model, how it is the same way. This for this, what is this is having? This is having an algorithm within itself, and it is having a param, like what are the parameters it has to be there, how many times of splits it has to do it. Yes. This is the data. Data is not there. Now you have to feed the data. What fit x underscore ss and y. Now it will split this data 10 times and it will learn from this data. No need to do it. Now you see this. Automatically it will do it. Okay. It's done. But it is taking some time. Yeah, it will take some time. It's done. It's done pretty quickly. Okay. Usually it will take, sometimes if you are using the local computer, it will take a lot of time. Okay. Now I want to see that it model dot, I have it like results over here. See the results. This is the results. You ask so many results, it is giving so many results. It's not that problem. Now let's see these results in a more organized way. pd.data frame. So this is nothing but an how you see this proper results. Now, if you observe it, it gives us the mean fit time, how much time it took it to fit in. Okay? Now, score. And here you see the combination, param combination. Then it is C is equals to 1 and RBF. Then the split is like this: score and test score second time, third time. For because how many times you give? 10 times. So it will give you test score 10. Now you got 1 and 1 also. And your mean is this one. Mean is 0.977. Okay. What is this rank? In all the combination, this is the best second rank. So that means there is one more is there, best one. This is the one which is saying the best. Even though the score is less, the score is more. See, 97.888. Now, there is a third one is there. This is the one, 97.53. Okay. Now, which one you want to take? Definitely you want to take the best one, right? See how many you got the scores. This is done all possible combinations. See, 0.1, RBF 0.1, sigma 0.1, linear 0.1, poly. Again, then if you have multiple, it will show you the multiple, like there will be hundreds of results. Okay. Now, this is for your information. Usually no one will be worried about this one. All they will do it is grid model. Okay, we gave the grid model only, right? Yeah, grid model. Model dot, we are having something called as best score. And which combination is this? You have to know which combination, right? What combination we got this? There is something called as best param. And I gave the 5.0 and kernel is equals to RB. Alright, guys. This is the way you will be doing it. Now you got the best score. This. So you can go. You confidently you can say that this is the best score you can get. Okay. So take the Irish data set and start it. Do it. Take the Irish data set, guys, directly from the. There is one more. Is there? Do we have the social data set with us? Write out with the social. There's a small one. Oh, it's in that. Chamber again. Start. Okay. Social data set se karo. Now take the data set. Simple way, guys. First do it with a simple split. And then you apply with the cross validation. Then you go to the grid search scheme. Okay. Again, you are going to take the two of them. If you want to take it more, it's up to you. It's up to you. हाँ हाँ फिर SVM ही यूज कर रहे हो ना. Import pandas as PD. You can apply any of them. Whatever you did it till now, you can apply them, any of them, and you will get this output. एक बार उनसे जाके पूछो. Anyone wanted to join as a mentor? No. कौन? श्रीकांत. नहीं, मैंने आपको नंबर दिया था ना उनका, उनसे बात किया. सिर्फ उन्हें कॉल करके बता दो. सर मुझे कोई कॉल ही नहीं कर रहा हूँ. मैं तो ऊपर कोई प्रवीण रहता था. एक्चुअली ही इज द वन हु इज टेक केयर ऑफ द लैब. ऊपर जाके पूछो. फिर मैंने रिज्यूम दिया है, क्या हुआ. श्रीकांत से बात करें तो आपसे बात करने के लिए बोल रहे थे. Because that's a very good opportunity where you can keep up the things. Shekhar, it's up to you which one you want to go with. You can do the same thing with the logistic regression. You can do it with the KNN or SVM. Anything you can do it, but you have to go with only one. Not you can do with the multiple also, but only one will be acceptable because you will be getting the best of the score. Only one. Guys who are online, just take the social data. I think that I have already shared with the social data with you. So so convert the gender, guys. Important. Convert the gender to the label encoder. Sorry, ordinal. One horse. Sorry. Df social dot drop user. Next, क्या करना है? What do you have to do it next? Encode it. How to do that? pd dot get underscore dummies. Which one you want to do it? I will give it a complete. I got it. And I will use it as drop first. And this I will make it as true. Okay. I'm dropping it completely. Now my data frame is perfect. Okay. Now I want to rearrange the columns. How I'll do it? Df social is equals to df social, and whichever the columns you want to rearrange them. कितना? What you're doing now? Studies completed. MS. Good. So rearrange this one, guys. I want to keep the gender in the starting. Social. Okay. I guess you are going to get it, guys. Now next is what? Splitting. Just apply the splitting from sklearn dot model selection input train underscore test underscore split. Now train underscore test underscore split. I want to give it as x comma y. I didn't split it by xy first. This is equals to f social top of what purchased. Okay, now y is equals to df social of purchase. Now here I'm going to split it with size. Size is equals to 0.20. I'll give it as 20%. Then I'll give it as, that's it. I will not do it anything else. Here I will store it in train, comma x test, comma y train, comma y test. So that when explain dot shape, comma x test dot shape. Okay, explain dot shape, comma x test dot shape. I put it. Now I will create my model from sklearn.svm import svc. Now svc1. Explain y train. Now run it. Now svc1 dot store x test y test. 81%. Now let me apply the scaling mechanism. Okay, scaling is now from sklearn dot preprocessing import standard scalar and s dot fit explain and ss dot fit so transform explain underscore ss. Clear, guys? You got it till here? Finished? Now I made that. So now I am going to transform my testing data also. Transform x test, and this will give me x test underscore ss. Now I got my explain and x test. Now I will create a one more model. svc2 is equals to svc. Now svc2 dot fit explain underscore ss by train. Okay. Now svc2 dot score x test underscore ss y test. 91% I got it. Previously it was 81. I've been increased with 10%. That is 91% I got it. Huh? नहीं, SVC से किया हमने. I'm not using anything else apart from SVC. You try it out with the different things. Huh? हाँ, नहीं logistics से मत करो. We are doing SVM, right? You do it with SVM. After completion of all these things, you combine the KNN, SVM, and SVC logistic, and then you try it. Now applying the cross validation, guys. आ रहा है? इसलिए बोल रहा था ना यहाँ करेंगे ना वहां करेंगे, वो तो पक्का है। वो आ जाएगा क्योंकि वो सिस्टमैटिक जा रहा है ना, यहाँ पर समझ में नहीं आएगा आपको। एक एक तरीके से गया तो आ जाएगा आराम से। वो स्ट्रांग रहे तो ये खेल ले सकते हैं। Guys, I am applying the cross validation from sklearn dot किसमें रहेगा, मॉडल सिलेक्शन ही ना, हमेशा कंफ्यूजन। Put a cross val for and I am going to use the k fold. Now k fold I can give it as n split. Guys, please practice each and everything. अगर एक भी we are not practicing, you will be losing that. So that's the reason why I will ask you to do the encoding, do the scaling. That is mandatory. At least till you get the job. After that, if you lose it also, it doesn't make any sense. Then KF అదే కదరా కూర్చోయడం చెప్తా స్విచ్ చేశాను వస్తుందా ఎర్రర్ లేకుండా మనకు వస్తే కూర్చోటి వచ్చేస్తాను. Now I will apply the cross val. Now I will create a new model SV2. Now here I will apply the cross val 4 and 3 and we are going to give it x comma y. This will give me the score. Now I will apply the mean. %76% is the mean without doing the scaling. Now I will apply the scaling over here. Cross val. Now I will do it as from sklearn preprocessing import SVM standard scalar. Now SS1 is equal to standard scalar and SS1 dot fit of x underscore SS1. Okay. Now I got the data over here, which is fit and transform. Now I'm going to apply the once again the cross validation. Now scalar dot model selection import cross val of k fold. I will take it as n splits 5 of them and I'll get kf1 and cross val score CV is equals to KF. Now this will get me the score. 42 minus 42.9. This is 90%. So previously I got it 76%. After applying the scaling and validation, I got it 90%. Okay, guys. Now see this completely. Okay, whoever didn't get it. First, you took the data. In this, the user ID is useless for us. Remove the user ID. And then I got the data. I applied the scale like encoding. So I've done the PD get dummies. I got the gender with top first. I got the gender as male. Then I rearranged the columns. And then I split it to X and Y. You know this very well. Now I have done the normal splitting over here. Okay. X test, Y test, and X train, Y train. Then afterwards I created an alarm bit ribbon. Now scalar.svm input svc. Now here I am passing on the normal data, normal without scaling. So I got it 81%. Same data which we did it with the logistic regression. We were getting the 60. Now we got it 80. Okay, the same data I applied the scaling mechanism. So here I don't know that whether it will give it better or not. I tried it. So I did the scaling and then I got it as 91%. But this is not an acceptable one because we have not done a cross validation. We have done it just a normal split and we did it. Now when I run it again, it will change. So to avoid that, I did the cross validation without doing the scaling. Now I took the cross validation, we fold and splits, I created a new object, and then cross val score is equals to X comma Y is equals to CV is equals to KF. Okay. Then I got different scores. In that I got it 76%. Okay. Now previously I got it 80%. Now this is a reliable one. Then what I did it cross validation with scaling, feature scaling. So I took the X value, I applied the feature scaling, I got it XSS. Then I took the again KF and splits and again a new model. I passed on to the cross validation and I got it 97.5. Now is this the perfect one? Yeah, it is perfect one, but we can recheck with the grid search CV. So I want you to do the grid search CV and I want you to do the random search CV, randomized search CV also. Remember? Any questions, guys? Now this is the reason why this is called as very powerful, because when you don't have the normally distributed data, that is data is not normally, that's linearly not separable data, you can easily get a perfect accuracy with this. This is a very, very powerful algorithm. And tomorrow we are going to start with our decision tree. Okay, decision tree is again, once you get the decision tree, then you will be having, you can do the random search CV, random forest very easily. And your grid search will be, grid algorithm will be very easy. And ADA boosting is also very easy. So random, your decision tree is very, very important, guys. Now from here, I want you to apply the grid search CV and random search CV over here, both. The grid search and you will get it. And each and every algorithm, whatever we did it, you are going to look out for with this one. Okay, now you are getting Confused? రావట్లేదా? క్రాస్ వాలిడేషన్ చేయాలా? ఆ ప్రాక్టీస్ చేయండి వచ్చా. Got it? Guys, how many people are comfortable with this? All of you. क्या हुआ सूरज? सो रहे क्या? क्या हो रहा है? Guys, I will share this one, and if possible, I will complete this grid search and I will share it. And tomorrow we are going to see it with decision tree. Guys, I'm ending the class.